welcome to Epic Learning Skills. Today in this video we are going to study about the integer data types, in which we will study about the unsigned short data type, signed short data type, 6C++ integer data types, integer and long integers constant, hexadecimal and octal constants. So first of all, data type. Computer programs collect pieces of data from the real world and manipulate them in various ways. There are many different types of data. In the realm of the numeric information, for example, there are whole numbers and fractional numbers. There are negative numbers and positive numbers. Then there is a textual information. Names and addresses, for instance, are stored as a group of characters. When you write a program, you must determine what type of information it will likely to be encountered. If you are writing a program to calculate the number of miles to a distant star, you will need a variable that can hold very large numbers. If you are designing software to record the microscopic dimension, you will need to store very small and precise numbers. Additionally, if you are writing a program that must perform the thousands of intensive calculations, you will want data stored in a variable that can be processed very quickly. The data type of a variable determines all of these factors. Although C++ offers many data types, in the very broad sense there are only two categories. First one is the numeric. Numeric data types are broken into the two additional categories, integers and floating point. Another type is the character. Integer are whole numbers like -2, 19 and 24. And floating point numbers have a decimal point like -2.35, 19.0 and 0.024. Additionally, the integers and floating point data types are broken into even more classifications. Your primary consideration for selecting the best data type for a numeric variable are the following: whether the variable need to hold integers or floating point values, the largest and the smallest numbers that the variable need to be able to store, whether the variable need to hold the sign both positive and negative or only unsigned, just 0 and positive numbers, and last one is the number of decimal places of precision needed for the values stored in the variable. So let's begin by looking at the integer data types. C++ has different data types for storing the integers. On most computers, each of these has either 2 or 4 bytes of memory. The number of bytes a data type can hold is called its size. Typically, the larger the size a data type is, the greater the range of values it can hold. As a byte is made up of 8 bits, so a data type that stores data in the 2 bytes of memory can hold the 16 bits of information. This means it can store 2 power 16 bit patterns, which is 65,536 different combinations of zeros and ones. A data type that uses the 4 bytes of memory has 32 bits, so it can hold 2 power 32 different bit patterns, which is 4,294,967,296 different combinations. What these combinations are used for depend on the data type. For example, the unsigned short data type represents the value 0 through positive 65,535. The short data type, on the other hand, stores both the positive and the negative numbers, so it uses its 16-bit to represent the values from -32,768 to positive 32,767. So our next topic is the 6 C++ integer data types. So the table shows all the 6 C++ integer data types with their typical sizes and ranges. Depending on your operating system, the sizes and ranges may be different. So here are some of the examples of integers variable definition. Notice that an unsigned int variable can also be defined using only the word unsigned. If you notice in the above table, the int and the long data type have the same size and ranges. and the unsigned int data type has the same size and range as the unsigned long data type. This is not always true, because the size of integer is dependent on the type of system you are using. Integers are at least as big as short integers. Long integers are at least as big as integers. Similarly, unsigned short integers are the same size as the short integers, and unsigned integers are the same size as integers. So our next topic is integers and long integers constants. If you look at the following statement, int floors is equal to 15, rooms is equal to 300, suits is equal to 30. This statement contains the three integer literals or constants. In C++, integer constants are normally stored in the memory just as an int. One of the pleasing characteristics of the C++ is that it allows you to control almost every aspect of your program. If you are in need to change the way something is stored in the memory, the tools are provided to do that. For example, what if you are in a situation where you have an integer constant, but you need it to be stored in the memory as a long integer? C++ allows you to force an integer constant to be stored as a long integer by placing the letter L at the end of the number. So here is an example. On a computer that uses the 2-byte integer and the 4-byte long integer, this constant will use the 4-byte. This is called a long integer literal or the long integer constant. So next comes hexadecimal and octal constant. Programmers commonly express values in numbering system other than decimal or base 10. Hexadecimal, base 16 and octal base 8 are popular because they make certain programming tasks much more convenient than the decimal number do. By default, C++ assumes that all integer constants are expressed in decimal. You express hexadecimal numbers by placing 0x in front of them. So here is how the hexadecimal number F4 would be expressed in C++. Octal numbers must be preceded by a 0. For example, the octal 31 would be written as 031. So I hope that you all have been clear about the integers. If you have any query, do comment in the comment section below or email me.